Alright, grade 10s, so we've looked at position time graphs, we've looked at acceleration, and now we're going to look at velocity time graphs. So a velocity time graph shows us the acceleration of an object over time. So the slope of a graph on a velocity time graph tells us the acceleration of an object. On a position time graph, the slope told us velocity. On a velocity time graph, the slope tells us acceleration. So just a heads up, we can use the slope formula to calculate acceleration. We've also worked with our acceleration formula, so either one of those will work to calculate the acceleration on a velocity time graph. So let's start with an object that has no velocity on a velocity time graph. So to show that an object has stopped moving on a velocity time graph, the velocity must be at 0 meters per second. And there's only one spot on a velocity time graph that can show that, and that's right along this x-axis here. So you'll notice this line is in blue. That's to show that we drew a line along the x-axis showing that this is 0 meters per second. So this object would not be moving. So it's really important to note that that's the only place on a position time graph, anywhere on the graph, if there was a flat line, that meant the object wasn't moving because the position wasn't changing. But on the velocity time graph, the only spot where there's no velocity is along the x-axis. So if you draw a flat line anywhere else, that means you have a constant velocity on a velocity time graph. So let's look at that constant velocity. So a car with a constant velocity has zero acceleration. So they're just traveling at a constant velocity. So in this example, we are traveling at 10 meters per second, and that does not change. So that's how we would get a flat line on a velocity time graph, because we're traveling at 10 meters per second for 1 second, and still again for 2 seconds, 3 seconds, 4 seconds, 5 seconds. That's the same as on this little diagram here. We can see our position is increasing by 10 meters every second, so our velocity is 10 meters per second. And again, that's a flat line anywhere else. So if it was a velocity of 1 meter per second, it could be way down here. Velocity of negative 10 meters per second, which again just means we're traveling in the negative direction in this case. So yeah, again, you can just see the velocity stays the same. So that's a constant velocity. Again, make sure that you understand that no velocity must be on the x-axis on a velocity time graph. And it can be a flat line anywhere for a constant velocity on a velocity time graph. This is going to be a little bit confusing with position time graphs, so you have to really understand what you're looking at and make sure you look at your y-axis and your x-axis to understand what sort of graph you're looking at. If it says velocity on the y-axis, it's a velocity time graph. If it said position, then that would be a position time graph. So let's move on to changing velocity. So now let's consider a car moving with rightward changing velocity. I'm not sure why that picture was like that. There we go. So rightward meaning in the positive direction, changing meaning that it's either speeding up or slowing down. So this car is moving in the rightward direction and it's speeding up or accelerating. You can say accelerating as well. So since the car is moving in the positive direction and speeding up, it's said to have a positive acceleration. So here we went from a position of 0 to 2, then 2 to 8 meters, then 8 to 18. So we increased by 2 and then by 6 meters per second. So our velocity was changing for that object. So yeah, we can tell that things are increasing. So we have a changing velocity. So this would represent a changing velocity graph. So we can see our velocity is 10 meters per second here, 20 meters per second here, 30 meters per second here. These two don't line up. These are just two examples, so you can kind of visually see the changing velocity of speeding up. So right here we were at 10 meters per second was our velocity. Now we're at 20 meters per second of a velocity, 30 meters per second. So those are all increasing, getting faster. So on a velocity time graph, anytime there's an angled line, whether it's an upward angle, downward angle, any angled line, that means the object has an acceleration. the object can be either speeding up or slowing down in either the positive or negative direction. So you could be slowing down in the negative direction, you could be speeding up in the negative direction, you could be slowing down in the positive direction, or you could be speeding up in the positive direction, and we're going to take a look at those and how to tell what an object is doing right now. So we'll look at the direction first. How do you know if it's the positive or negative direction? So since the graph is a velocity time graph, the velocity is positive whenever the line lies in the positive region. So anytime you have positive y values, or you're above the x-axis of the graph. Also, the velocity is negative whenever the line lies in the negative region. So it's below the x-axis, you have a negative y value. So let's look here. So this is our positive y and x region. So in this case, this object would be speeding up. In this case, this object would be slowing down, and we'll talk about that next. But both of these are on the top part of the graph. So the top half of the graph is the positive area, and then down here we have this negative area. So again, negative doesn't necessarily mean slowing down, it just means traveling in the negative direction. So in this case, this object would be slowing down in the negative direction. This object would be speeding up in the negative direction. So again, this is different than a position time graph as well. So on a position time graph, anytime the line was going at a downward angle, so anytime the line was traveling like this on a position time graph, that meant we were traveling in the negative direction. Anytime we were traveling with the line going up and to the right, that meant that we were traveling in the positive direction. So velocity time graph is different. Anytime you're in the positive region of the graph, you have a positive or you have a positive direction. Anytime you're in the negative region of the graph, you have a negative direction. Okay? So again, confusing with the position time graph, really keep that straight in your head. So now you want to know if an object is speeding up or slowing down. So an object is speeding up if the line on a velocity time graph is changing from a location near the zero velocity point to a location further away from the zero velocity point. So that is, if the line is moving away from the x-axis, the object is speeding up. And conversely, or opposite of that, if the line is moving toward the x-axis, the object is slowing down. So here, let's take a look. So at this point, we were traveling in the positive direction at 3 meters per second. The line went away from the x-axis, so that meant we got to a velocity of 9 meters per second. In this case, typically we tend to think negative, that means slowing down. Again, this is just telling us we're in the negative direction. So say you were traveling to the left at 3 meters per second, and then you continue traveling to the left, but you sped up to a velocity of 9 meters per second. So again, anytime on a velocity time graph that you're moving away from the x-axis, that means you're speeding up. So this would be speeding up in the positive direction. This would be speeding up in the negative direction. In this case, we have slowing down. So if we're looking in the positive first, we were going at a velocity of 9 meters per second, and we slowed down to 3 meters per second. So you can see we went from a higher velocity of 9 to a lower velocity of 3, meaning we slowed down. Here's the same thing, we're just in the negative direction. So if you were traveling to the left or you were traveling downward, whatever negative direction we're looking at, we were traveling at 9 meters per second in that negative direction, and then we slowed down to 3 meters per second in that negative direction. So again, slowing down is coming towards the x-axis because we're going from a higher number to a lower number. It's just dependent on if you're in the positive or negative direction in this case, right? So both of these can be slowing down. Both of these are speeding up. Again, it's just what direction are you going, in the positive or in the negative? Okay, so I have a practice question down here for you. We're going to do it based on this graph here. So it says describe the motion of the object and calculate the acceleration. So like we talked about before, you can use the slope formula, or the acceleration formula that you've been working with. They equal out to the same thing, but if slope makes more sense for you on a graph, then please use that. If acceleration makes more sense, then please feel free to use that as well. So I just did one example here for you. So for the description of this object, from the point A to B, I would say this object speeds up, right? Because we're changing our velocity from 0, we got to 20, up to 40, up to 60 meters per second. We're going in the positive direction as well. So object speeds up in the positive direction to a velocity of 60 meters per minute. Sorry, I said second before, it's per minute. And that took us 10 minutes. Okay, so that's how you would describe this. So again, tricky, this isn't a position time graph. B to C, we have to be sure that we understand that this would not be staying still. Okay, that's your hint. The only place on a velocity time graph that you can draw an object with no motion is on this 0 axis at 0 meters per second. Okay, so if you have any questions about these examples or how to calculate acceleration, take a look back in your notes for the acceleration, look on the position time graph for the slope formula. If you have any questions after that, please let me know. And if you have any questions about any of these graphs or anything in this set of notes, please let me know with a message on Edmodo.